All right. Hello, everyone. Welcome to the analysis meeting on April 12th, 2022. This meeting is not going to have that many slides, but I wanted us to mainly talk about the upcoming week because it will be a little busy. There's some pretty big things we need to figure out and figure out fast. So apologies for those who aren't necessarily directly related to these tasks, although you are always welcome to help out. On our agenda, we have our usual check-in, which I forgot to make the slide for. Then our Open Rocket intro project, which Charlie will be presenting about, and then talking about the potential MMM design. So in the lab last week, Frith and Arturo and I were discussing a potential design that we could use for Zenith. So I'll update y'all on that. Then a new kind of mini project that needs to get done this week is the Armod Fiber FEA regarding the centering ring material. And then the centering ring material trade study, along with a screw calculator update, and ending it with questions. So for the check-in, I guess just let me know what you guys have been working on recently, and in particular, those who may not have been involved with the tasks that I'm going to be talking about as well. Armod does not really stand for anything. It's just kind of what we were naming when we were doing thin stuff. We called. I'll explain it. When we were doing thin stuff, we named our different configurations as like Zenith R or ZR, because when we if Will had a configuration, it'd be Zenith W or stuff. So R was just for my name, and then mod was just to show that it was a different design than just the regular R from way back from the fins. So now Armod Fiber is just representing the Armod configuration with the shortened motor sleeve and the MLA fiberglass. Thank you, Bob. You just explained. Okay, cool. There are no check-ins. For me, I was honestly have not been too focused analysis-wise, which it's kind of been why we're in this predicament. So I apologize for that, but ready to put in the work this week. And in the lab last week, I was working with Frith, Arturo, and Omar online on the centering ring material trade study, which is where I kind of realized all these things that need to get done are, and the way in which we should get them done. So that's what I'll be talking about. But before we do that, I wanted to give Charlie the chance to present his Open Rocket and what he learned from it. So the floor is yours, Charles.
Hello, everyone. Wait, Ravi, is on the slides, or should I share my thing?
You can share your screen with your design. But,
okay. So, wait, I've never done this before. What can I do? All right, so as this is my first, wait, can you see this?
Yes.
All right, as this is my first semester in the Rocket team, and also first semester in analysis, Ravi thought it would be fitting for me to learn how to do a model on Open Rocket by trying to get an apogee of above 30K with any material, and this is what I came up with. I think I learned a good amount about I guess what works and what doesn't. I started off by basically modeling my rocket kind of dimension-wise similar to Zenith, the nose cone and the body. And then I added the payload also. But first steps I took to increase apogee really was like changing the shape of the fins, as you can tell. And then with that came the issue of having my stability too high, the number too high. And then that's when I started to change the weight. So like I added a weight at the nose cone. I also changed some of the materials, but most of the materials I went with were carbon fiber or fiberglass to keep the weight down overall. I don't really know what else to talk about.
Oh, that's cool. Thank you. I guess one thing I definitely want to talk about is overall your design looks really solid and it's very similar to Zenith, as you mentioned. But could you tell me why, or take a guess as to why you never see fins this drastic in real life, if it theoretically works on open rocket?
My guess would be that when you're traveling at such a high speed, maybe the fins would snap or have some, I don't know, issue with the material, I guess.
Yes, you're correct. Yeah, I think the main concern here, obviously, apart from the issues you'd have with just launching like that and loading it onto a rail is, yeah, once you start traveling at a high speed, those fins are definitely going to flutter or hit the divergence velocity required for them to just completely shear off. So that's why you always see fins that are relatively compact and within the general frame of the body. Nothing like Sputnik 3 or 2 over here. But thank you. For open rocket wise, I guess it is kind of a lower point in the semester, but it's always good to know how to use it. And I guess now with any like modifications that we're making, I think I'd feel comfortable giving you the task of handling that and being able to adjust things on the actual Zenith open rocket. So good job and thank you. If you could
Thank you.
stop your screen here. Thank you. Okay, now into the first bit of the meeting, the potential MMM design update. So mainly for Prith and Arturo. When we were talking in lab, we had come up with this design, roughly kind of replicating Oberon's MMM in the sense that with these 3 centering rings, we wanted to make the bottom and the middle centering ring act as the same centering rings that were present in Oberon's MMM and bolt to the fins using L brackets. The reason this idea was proposed and developed and came up with was because we weren't particularly sure in the strength of laying up the fins onto the motor sleeve made of fiberglass. But after talking to Gustavo and Structures, they considered this option before, and they determined from their research that a tip-to-tip layup is generally the strongest method to secure the fins, and that's kind of an industry. I don't know if industry is the right word, but within the rocketry world, that's long been considered to be the best way to secure fins to a body. And that's why you also see a lot of fin cans. And if you get to spaceport, then you'll see a lot of other teams with fins that are permanently attached to their body, most likely through a tip-to-tip layup method. So that's why we're going to end up going with that. Another thing Irvin pointed out to me yesterday is that we already bought the cloths, the carbon fiber cloths to do this layup. So I don't think it would be the best idea to then switch and have to invest even more money in completely redesigning and switching to an MMM. Another point Gustavo instructors brought up was that they were worried about the strength due to the difference in flight forces, I guess, between 30K and 10K. For 10K, I think obviously the MMM was suitable, but with our configuration and the boat tail and really just the differences in motors and the first few seconds after launch, they're more confident in a tip-to-tip layup. And I think I would agree with them because they've done the research and we haven't really looked too much into it. But yeah, wanted to update you guys on that because I know we were considering it heavily in the lab. Okay, now the Armad Fiber FEA. So the Armad Fiber is the open rocket configuration, the most recent one, the one that we've kind of been going by with a much shorter motor sleeve and the 3 centering rings and the back centering ring kind of split into 4 to accommodate for the boat tail and its shoulder. So with our end goal by this week, well, I guess our end goal by the end of this week or really Thursday night is to determine for that MLA assembly, we want to know what the centering ring material is, and we want to know what the centering ring thickness is. So the way I thought of approaching this problem, which is definitely up to y'all to interpret and critique, because it may not be the best way to approach it, but it's kind of what I have theorized. But I think it would be best to first develop the CAD for an Armad Fiber setup. It really just has to be the lower airframe section. So kind of the motor block, the whole MLA assembly. And then I think we already have like some of those components. It'll just be like the motor sleeve and the centering rings that will need to be CAD'd from scratch. But using that CAD, if we could run comparative FEAs for that setup. So using all 4 materials from the trade study, so plywood, aluminum, fiberglass, and carbon fiber, changing that material of the centering rings for every different FEA, seeing how that responds to the forces that we're estimating from the landing impact, which we can use from the boat tail FEA. You can start with like a 3/4 inch thickness and then scale up or down as needed with the force that's experienced and with the different materials. So the main goal is to get a thickness value for each of the centering materials we're considering to be used on the trade study. Also kind of secondary to that is that we want to verify the distributed load for the Armad Fiber, as it will be a little bit more intense and I guess stress inducing than just the regular Armad, where we had the full length motor sleeve and the centering rings much more spaced out. Because it's a lot more compact, that stress is going to be a lot more concentrated in those centering rings and in the entire system. So I know it's kind of quick and it's really approaching soon, but for Omar, Arturo, and Prith, and obviously I will be there to help you guys out. If we could get this done by Wednesday night, that would be ideal. If you do need more time to work on it, then absolute latest is going to be Thursday during the day or Thursday at night. We have a meeting with Eric. I think the leads and Eric have a meeting after the AIAA general meeting on Thursday night, where we'll be talking about cutting the fins and also these centering rings that need to be cut. So if we need to know by then the material and the thickness for these centering rings, hence the hurry and the concern with this. But really it's kind of just get started as soon as possible. And I wouldn't worry too much about documentation and reports for now. Just for this week, we just need to get these values in, and then maybe next week and the week after, we can start looking at documenting what we did this week. Are there any questions regarding this task in particular?
Okay, thank you. So if we can get it done by tomorrow night, I think it'll really be good if we can have at least the CADs also done by Thursday. That we can just email those to Eric. And then also get that purchase order for at least the fiberglass if we need to, and have that purchase as soon as possible. Because first, the thing is going to be the fence. I think we do have the CAD for that, right? The SolidWorks file. We can email that to him tomorrow, and then the rest on Thursday.
Yeah, we should. Yeah. Go ahead.
I was just gonna say, just to, I guess, make sure. So the CADs that we need are the center rings, motor sleeve, and I mean that's pretty much it for the most part, right?
Yeah, I think we technically have a motor sleeve, but it just needs to be shorter. Remind me to tell you guys the length that we have in Open Rocket. I think it's roughly 20 inches, 25, if I'm not mistaken. But yeah,
If you could just send, oh, sorry.
No, you go, you're good.
I was gonna say, if you could just send like a screenshot of what you have on Open Rocket with like all the dimensions we'll need, that'd be pretty beneficial.
Okay, cool. If we finish in time before the general meeting, I'll get on Open Rocket and do that and send it to the Discord right away.
Okay, cool.
On the sleeve. Okay, the motor sleeve is listed at 22 inches long, and the centering rings, they should be on there at least. Well, yeah, you can start with them at 3/4 of an inch thickness, so that doesn't matter. The actual CAD,
The centering rings,
I guess inner and outer diameter for the centering ring.
for all three, the outer diameter is 6 inches. The inner diameter is 4.024 inches. And the top one, the middle one, that should be the same. Actually, they're all three the same.
Yeah, and they should all be the same. Or except for the third one.
Yeah, the bottom one should be different.
Yeah, okay, so I don't know if y'all are writing this down right now, but the inner diameter for the top two centering rings should be 4.024 inches with an outer diameter of 6. And then the bottom centering ring should have an inner diameter of 4.024 and an outer of 5.9 to match the
Should be like
shoulder.
that. We gotta ask structures.
Yes.
because I think they won't have the diameter for the both those down.
Mhm. I think for now, keep it at 5.9, but it will be subject to change. And then with the boat tail that we have catted, I don't know if y'all want to check or if you know, but do you know the shoulder length and then the diameter of the shoulder?
I think at least the one that I'm thinking about, isn't shoulder length 6 inches?
It should be, but when we did the FEA, I don't think we knew that unless we had already catted it to be a 6-inch shoulder.
Then, okay, it's probably 4.
Okay, so then you'll have to change that as well.
So when we send you guys the CAD, are these the CADs that you're gonna send Eric for him? Is he also machining the centering rings?
Yes.
Okay, so I was gonna say, because I'm assuming that like the 6, I don't know if you guys took into account the clearance like between the centering ring and like the tube with like the 6-inch outer diameter, for example, or between the centering ring inner diameter and the sleeve, or like did you just exactly match the dimensions? Like 6-inch outer diameter of the centering ring is like matching the 6-inch of the tube, because I don't remember what the diameter of the tube was.
It is just matching because the inner diameter of the airframe is 6.
Gotcha.
What is a thing you put in the chat?
What?
In the chat, you said 1/4-20 threaded insert full diameter.
I like that. I actually did not write that.
Okay, cool. Okay, so kind of more simple for the material centering ring material trade study. Obviously, we'll just put a quick pause on this for now, and then once the results of the FEA and the thickness is determined, then we'll just use those values and finish up the decision matrix. For this week, I think we just finish the decision matrix so that we have something down and we'll know which option is best by Thursday night. I think we're going to go with fiberglass, but I do want to have a decision matrix there in place so that we can definitively say why we're going with fiberglass. You may need to up the weight percentage of cost on the trade study, because I mean, that's going to be the main reason why we don't go with carbon fiber, because it will perform better than fiberglass, but it's just too expensive in its form. So maybe adjusting the weight accordingly would be good as well. But that's mainly for after we figure out the centering ring thickness. So for Omar, Arturo, and Prith, and then Nico, I don't know if you're planning on being in lab as well on Wednesday, but if you could help out with that as well, that would be super helpful and much needed, I think. Okay, cool. No worries. Were you planning on making it to lab at 6? Oh, okay.
Who are you asking?
I was just asking Nico if he was able to.
Okay.
For Irvin, the motor sleeve is the fiberglass thing that will cover the motor casing.
No, hold on. Somebody else in here has my name. I think it's Goose. And they sent the first message saying OD motor too.
Why do they have your name?
I don't know.
There are 2 Urban
Yeah,
Story.
that's Goose.
Yeah, okay, so if it's Gustavo, he said the outer diameter of the motor tube is the
It's the motor tube
4.024.
and motor sleeve.
Yeah, are you referring to the sleeve or the actual like motor?
It should be this.
Motor sleeve could be 4.0.
I think it's just the naming that we're arguing about. Or not agreeing
Well, I
Oh, yeah,
just want to
that's-
make sure that it's referring to the same thing.
Yeah.
Okay. All right.
Okay, cool. Last topic of discussion is the screw calculator. Omar, I know you were kind of touching on this before, but Gustavo brought up last night that number 12 screws do not have any press in or push in. They only have helicoils, which from past experience, I don't think would be a good idea. And it's been kind of painful to implement. It's someone we don't have much experience with. So if we can find another screw size that has press in or push in inserts that can work for plywood, G10 fiberglass, carbon fiber, and aluminum. I want you guys to mainly consider fiberglass and carbon fiber, kind of for the reasons stated within the trade study and what I think we're going to end up going with. Then that would be excellent. I think on the screw calculator, which you can find in the drive under testing and analysis, and then centering ring, or I think it may be on the front page as well. This part of the desired hardware diameter, you'll be able to change from the number screw that you have. So a number 12 screw has a 0.216 inch major diameter, which is what you'll input in the calculator here. And then it will spit out a number of screws that we will be required. You can adjust the factor of safety to get exactly 12 screws required, but do not go below 1.5 because that's the minimum threshold that we're looking at. So I guess the greater the factor of safety, obviously the better. But because the validation team is kind of at a standstill for work right now and the design team is a little overloaded, if Charlie, Will, and Amy, whoever can be in the lab tomorrow night, if y'all could work on this and really do just a bunch of research on different screws and their sizes, and if they have corresponding press-in inserts available, that would be good.
Could I share my screen just really quick, like 30
Yes.
seconds? Okay. Because I was working on this right before. I don't mean to like take anyone's work, but so the press-in inserts in McMaster car, like I sent a picture of it, it's limited to 1/4 inch and number 10, which like you said is really available for number 12. And I remember Gustavo yesterday was mentioning, you know, if it's possible to get the total number of screws to 8, and then like maybe reduce the total number of centerings from 3 to 2, if that's a possibility. We can do it because if we choose 1/4 inch screws, they have the corresponding screw size on McMaster card too. So I just wanted to, I guess, get his opinion if you want to stick to 2 possible centering rings, or do you just want to do 3?
I think something that I also want to learn from the FEA is how the load is going to be distributed. And I have a concern that with only 2 centering rings, it may not be enough, but that may also be offset by having I don't know, obviously a stronger screw in there, but I think having more, at least 3 centering rings would be better. But again, it's kind of how the FEA turns out.
Okay. Not use those inserts there for Friday. All right. I'll stop sharing.
Yeah, so I think we'll just have to do some research on what kind of things are available and at what size we're looking for, but mainly for Gustavo and anyone, I think, I mean, feel a lot better with having 3 centering rings than just 2. But want to see what y'all think about that.
I feel a lot safer with 3 also. Like a lot safer, especially that top one. And I guess the bottom and the middle one are really gonna help out with the defense. But again, I think it's gonna depend on what you'll find with that FEA and what Gustavo thinks too.
I guess if I could just say one thing, I don't want us to put all our eggs in like the FEA, especially the composite material, once we test like fiberglass and carbon fiber, just because it's pretty known that it's incredibly hard to find accurate material properties for a composite material. So I don't want everything to be completely based off the FEA. So I just don't want to like get y'all's hopes up in that aspect.
Couldn't you figure out by using aluminum or just any material what would be safer? Or like if we would be, like if it will make much of a difference having 2 or 3, if you just, let's say, use aluminum.
Yeah, I mean, we can use aluminum for sure and see how it will react. But I was just saying if like besides that aspect for like the 2 or 3 centering rings, just like the composite materials, I just want to say that.
Because right now we're using SolidWorks to conduct these analysis, and it doesn't really have very good tools for composite materials. Like right now, we're assuming like everything is linearly elastic.
Okay,
So the models aren't, gonna be super accurate. And I think what Omar's trying to say is that we shouldn't be over reliant on what the FEA turns out to be.
Yeah, I think that's a good point and a good thing to remember. I like Irvin's idea of doing the FEA with aluminum or just a material that we know will be better suited and better fitting within the FEA. But once we do move into like looking at stuff for fiberglass and carbon fiber and even plywood, then I think we'll just need to, I guess, see what happens, because we don't have much time and kind of need to figure out roughly a thickness that is that can work with our system. That's all I had scheduled to talk about, but obviously if there are questions or we want to go over another part, it's a good time.
Right now, but I think probably at the general meeting, I'll have some stuff. And I guess it's one last comment. If y'all can all please attend the general meeting, just over Zoom. There's a lot of good updates. That's it.
Yes, and I think I'm trying to think of different ways that we can validate the forces that the system will go through upon landing, mainly apart from an FEA. Unless we get really creative or complicated with free body diagrams and modeling each element.
did we ever decide on how we thought the reactions were gonna work for that discussion we had with landing, whether or not like the only loads that the schools would experience would be just of, like the weight of everything but the motor free assembly, like the lower assembly?
Yeah, it'll be through because we're gonna have the lip on the boat tail, right? So that will transfer it through the lower airframe, and then I think we'll end the motor sleeve.
The motor lift?
And when we land, yes, the motor lip at the bottom. We'll go through the motor sleeve,
The motor sleeve, okay.
yeah, and
Yeah,
then onto the centering rings and screws, and then the airframe. But I definitely. Cool. Thank you, Prith. Gustavo, I don't know what your schedule's like this week with other things, but I would really appreciate it if you could be in there tomorrow night to help us out. I think at least I could use some guidance as to figuring some of these things out. I appreciate it. 6 to 8 p.m. So. Yeah, for Charlie, Will, and Amy, I know it's kind of a rushed explanation, so I think I'll be able to provide a better idea of what I want you guys to do with the screw calculator in the lab. But for now, I would definitely take a look at what Omar and the rest of the team have put up with the screw calculator for now, and then definitely maybe start researching some screws with good precedent insert options that can work for us. And thank you, Gus. That sounds good.
Real quick, I think Gustavo said something earlier. Did he say not to use those inserts? Is that what you said, Gustavo?
He said,
Just
although
wanted to
they're
make
for
sure.
fiberglass, I would probably not use those inserts. They're for fiberglass plates and are quite wide in diameter. I know McMaster has like a lot of inserts, so I'm sure we can definitely find some.
Yeah, well, those were the only threaded or the press-in inserts. The rest were, I can double check, but the rest were like different, like threaded inserts and then a couple others. But we can, look, I just wanted to make sure that that's what he was referring to.
Well, with that, we'll end the meeting here, and we'll discuss more in the lab tomorrow. So please try and make it out, especially those related to the tasks at hand. Yep, thank you all for coming. Appreciate it. And I will see you tomorrow and at the general meeting in 15 minutes.